Imagine a celestial orchestra featuring an incalculable number of stars, planets, and moons that play in perfect harmony. However, for a very long time, astronomers have been baffled by one component of this cosmic ensemble: exoplanets. These are natural planets situated beyond our solar system, concealed deep within the Milky Way. An exoplanet that is strikingly similar to Earth exists among these numerous cosmic entities, which may surprise you so much so that it could be deemed our planets. Cosmic counterpart. Using the James Webb Space Telescope's perspective, we enter this fascinating field, examining Proxima B, which is just 4.2 light-years away. The James Webb Space Telescope is transforming our exploration of these celestial mysteries, bringing us nearer to deciphering their secrets. Imagine for a moment your mind drifting across the vast expanse of our galaxy, the Milky Way, which harbors more than 1 trillion exoplanets. To put this number into perspective, if each of these planets were the size of a grain of sand, they would not only fill the Grand Canyon, but would also form a new geological monument on Earth, a second Grand Canyon stretching for 4 miles. The fact that approximately 20% of these exoplanets have been classified as Earth-like in terms of their geological and atmospheric characteristics is even more remarkable. This indicates that there is a 1 in 5 chance that we will find our planet's twin. How was the civilization discovered by Webb? There are, still a lot of possibilities. Alongside these planets, there may exist another quadrillion moons, with their parent planets and rocky satellites like our own moon, engaged in gravitational dances. Now the cosmos offers an abundance of opportunities to discover celestial bodies that could harbor life or potentially support it. It is time to introduce the master artist, who is capable of painting its intricate details as we unfold the cosmic canvas. The James Webb Space Telescope, with lenses that far surpass the capabilities of even the most cutting-edge optical technology. This celestial detective outperforms telescopic instruments with unparalleled precision. The telescope's primary mirror, 6.5 meters in diameter, is 2.7 times larger than Hubble's. This immense size allows it to detect even the faintest flickers of stars billions of light-years away, while also analyzing the details of orbiting planets. What makes the James Webb Space Telescope so revolutionary is not just its unparalleled observing power, but also its advanced technology, which includes infrared sensors and spectrographs. These tools don't just observe, they analyze and filter the unique light signatures emitted or reflected by celestial objects. By doing so, the telescope is able to discern atmospheric conditions, compositions, densities, and even masses of distant planets. It acts as a space forensic tool capable of detecting water, organic compounds, and even oxygen, offering us insights into the habitability of distant worlds. The James Webb Space Telescope is more than just an improvement on the Hubble Space Telescope. This is a monumental leap forward, a quantum leap in scientific discovery. While Hubble's findings astonished us, the revelations from the James Webb Telescope promise to be even more spectacular. One of the most captivating celestial objects in the universe is Proxima B. Since its discovery in 2016, this intriguing exoplanet has captivated astronomers and scientists alike, possessing an aura of complexity and paradox that mirrors a Shakespearean protagonist. Why all the fascination? First of all, Proxima B is only 4.2 light-years away from Earth, so it is practically in our cosmic neighborhood. To put this in perspective, if you could somehow travel at the speed of light, you would reach Proxima B in a little over 4 years, about the same amount of time it takes for a TV show to lose its popularity or for a presidential term to expire. So, why is proximity so significant? The universe spans an astonishing 93 billion light-years, and finding a planet so close and so promising for scientific research is like finding a diamond in a pile of rubble the size of Mount Everest, a diamond that could hold secrets about life itself. In the vast expanse of the universe, Proxima B is a key piece in the puzzle, offering us clues that could redefine our understanding of habitability and life beyond Earth. Proxima B's importance is not just in its proximity to Earth, but also in the tantalizing possibility that it is not only Earth-like, but perhaps an Earth 2.0. Situated in the habitable zone of its parent star, Proxima B offers conditions that are neither too hot nor too cold, but just right for liquid water to exist. Imagine flowing waterfalls, winding rivers, vast lakes, and possibly even oceans as deep and mysterious as the Mariana Trench. However, before we begin to fantasize about vacations on Proxima B, let's take a look at some peculiarities. A single day on this fascinating exoplanet lasts a staggering 11 Earth days. Imagine sunrises that unfold slowly, heralding a new day, followed by extended sunsets that stretch long into the evening, creating golden hours beloved by photographers. Although this sounds idyllic, it has significant effects on the climate and habitability of Proxima B. How would human biorhythms adjust to such an extended daylight cycle? Would we need to eat 3 or 4 times as much in a single day? And would we sleep in the same way? The fundamental patterns of life, as we understand them, would be both eerily similar and yet strangely unfamiliar. It's as though nature is presenting us with a riddle wrapped in a mystery, testing our comprehension of what makes a planet habitable. But how do we gather reliable and accurate data about a world we've never visited? Enter the James Webb Space Telescope, deploying all its capabilities like a cosmic Swiss Army knife. It is more than just a telescope, it also serves as a versatile, space-based scientific observatory. Astronomers are able to not only observe distant worlds thanks to its cutting-edge engineering, but they are also able to examine those worlds with a variety of cutting-edge instruments that would make even the most prestigious forensic labs appear primitive. Utilizing sophisticated spectrographs, the telescope can examine the light that is emitted and reflected by these faraway planets. Each chemical element or compound within a planet's atmosphere absorbs or radiates light at distinct wavelengths. By interpreting these light patterns, scientists can essentially conduct a remote biopsy of extraterrestrial terrains. They are able to figure out atmospheric pressure, chemical density, and even whether or not oxygen, water, and carbon-based molecules are present. It transcends traditional astronomy. It is cosmic forensic science. With this groundbreaking equipment, we no longer passively wait for discoveries to reach us. We actively pursue them, dissecting the atomic and molecular building blocks of alien worlds. The James Webb Space Telescope is much more than just a watchful eye in space. It's a finely tuned scientific laboratory, interstellar investigator, and analytical powerhouse. All combined, it empowers us to transform our hypotheses about remote worlds into verifiable theories, ones that can be affirmed or dismissed through evidence. By broadening our cosmic perspective, this telescope is reshaping our understanding of what may lie beyond the confines of our own world. Just when it seemed we had uncovered every intriguing layer of this astronomical narrative, an unexpected revelation emerged, evocative of a scene from a sci-fi epic. Scholars utilizing the James Webb Space Telescope registered something extraordinary originating from Proxima B, a signal that was so unique and intricately patterned that it sparked a lot of discussion in academic circles and on social media platforms. This electromagnetic transmission, which was marketed as a potential technosignature, exhibited such complexity that it raised the possibility that it was the creation of a sophisticated extraterrestrial species. For a fleeting moment, humanity paused, collectively holding its breath, pondering whether this might be the affirmation we've long yearned for, proof that we are not solitary beings in the vastness of space. But as abruptly as it emerged, the signal dissipated. No repetition, no remnants, only a haunting silence, and a torrent of unresolved inquiries. Could it have been a cosmic fluke, a random alignment of natural forces? Or was it something more intentional, a coded transmission, or even a manifestation of an intelligence far greater than our own? The enigma of the signal lingers, spurring theories, debate, and wonder. Was it a one-off occurrence or part of a much larger cosmic narrative, one that eludes human comprehension? Though the mystery persists, our journey is anything but complete. The narrative of space exploration is still unfolding. Its latest chapters authored by Harvard scientists pushing the outer limits of our quest to find intelligent life. Unwilling to be confined by past methods, these pioneers are repurposing the James Webb Space Telescope as a type of interstellar night vision device. Their aim, to identify artificial light emissions in both the shadowed and sunlit regions of far-off planets, an endeavor with staggering potential. Visualize discovering an alien metropolis, aglow under its own artificial lights, radiating into the cosmos like a beacon from a civilization advanced enough to manipulate its environment. Such a find would not merely be monumental, it would redefine our place in the cosmos. Share your impressions in the comments below. If you found this vision enthralling, consider subscribing and liking as we continue navigating this exhilarating epic of astronomical discovery. This bold new frontier of space research is anything but ordinary. The James Webb Space Telescope, now fully functional, is not just a step forward in astronomy. It is a huge leap. Its capabilities stretch far beyond rudimentary observations. It is an essential instrument that might help us decipher the most profound questions about our presence in this expansive, ever-evolving universe. We stand on the edge of potentially uncovering deeply transformative truths about extraterrestrial existence. Each incremental advancement unveils more of the concealed realities awaiting discovery. The possibility that we might someday unearth unmistakable evidence of intelligent life is more than a whimsical dream. It's an emerging scientific milestone. Though the notion has captivated imaginations for decades, what sets this era apart is that we now possess the tools to chase it in earnest. Yet, the transformative power of the James Webb Telescope goes beyond the hunt for intelligent organisms. Its unparalleled ability to dissect distant planetary atmospheres and surface features offers a window into their potential for hosting life, a capability about which previous generations of scientists could only dream. Each new insight nudges us closer to resolving high-old existential queries. Are we truly alone? Or do companions in the cosmos await discovery? Proxima B, with its tantalizing likeness to Earth, gives us a speculative preview of what a parallel world might resemble. And the tantalizing prospect that it could support life someday is as thrilling as it is mysterious. Still, there are a lot of obstacles to overcome when venturing into the unknown. The secrets of Proxima B and similar exoplanets demand rigorous investigation. The distance from its star, its geological vitality, the chemistry of its atmosphere, and the presence of liquid water are just a few of the many factors that influence a planet's capacity to support life. The unexplained signal from Proxima B has introduced an entirely new realm of inquiry, prompting everything from cautious theories to wildly imaginative speculations about contact with intelligent beings. Was the broadcast truly an engineered technosignature, or just a coincidental spike in cosmic noise? The debate remains unresolved, but one certainty endures. We have only just begun to unravel the complexities of the cosmos. In the years ahead, the James Webb Space Telescope is expected to play an indispensable role in addressing these questions. As it continues to relay data that could alter our conception of the universe, we must remember our pursuit of knowledge is not a sprint. It's a multi-generational expedition. As our scientific instruments grow in sophistication, so too does our ability to probe deeper into the night sky, unlocking secrets long kept from humanity's gaze. Armed with tools like the James Webb Space Telescope, the future of astrophysics shines with promise. The mission to locate life, beyond Earth is not merely about discovering worlds that mirror our own. It's about grasping the core essence of life itself. Are life's building blocks a universal template, or is Earth a singular anomaly? Is Homo sapiens the lone intelligent species to gaze at the stars with wonder? Or are there others who have long mastered the cosmos? The answers to these profound questions may transform not only science, but also how we see ourselves. As we push the boundaries of our planetary neighborhood, and venture further into the interstellar unknown, one truth becomes increasingly apparent. The voyage is only beginning. We get closer to understanding the majestic and mysterious universe in which we live with each new revelation. And perhaps, just perhaps, we'll come to learn that solitude is not our cosmic destiny. As the James Webb Space Telescope deciphers distant exoplanets and detects signals from the farthest reaches of space, we must accept that the universe is a vibrant, evolving arena with infinite mysteries waiting to be explored. It tells a story that spans galaxies and eons. With each data point it returns, adding yet another piece to the bigger picture. More importantly, this epic exploration is not reserved solely for scientists and experts. It belongs to us all. The breakthroughs of today could forever shift how we understand our world, our identity, and our role in the unfathomable vastness of existence.